Hello, welcome to this video where we're going to be discussing modelling double height spaces in Heatpunk and how to think about these and how to make sure that we're getting the correct values within the project. So when we get to double height spaces, it's quite common that that may happen in a big hallway where it sort of has a double height entrance space, and there's a stairs, and then you kind of enter the landing on the top, but you've got, as you look up above your head, quite a high ceiling space there, and we want to make sure that we can model that heat loss correctly. But it's also quite common that for something like a kitchen dining room here, where we have an extension, that we have a big kind of vaulted space off the back of the house, but really it's a single story structure. So we want to look at how to model that. So if we were to look at this kitchen dining first, where we have a potential double height space, we don't necessarily need to adjust the height of this room because that's going to change everything here. Instead, we want to go into our floors and ceiling section. Let me just delete this from the plan for a second, and we can see we have our sort of bedroom or bathroom above here, which is on top of the front third of the kitchen. And then we have a section here that we want to model as our double height space. There's a couple of things we need to do. This section here is relatively easy, where we're going to bring in our region. We're going to set our heights. So this actually might be something like 5 meters. And that might come all the way down to our standard 2.4 meters. And we can add that in there. And we now have our correct vault in there. We can add some Veluxes, for example, just for the demonstration. And that's that modelled. Underneath here, we now have this front section, or the bottom section of our kitchen dining modelling correctly. What we haven't done, however, is thought about these top floor rooms, because technically both of these walls are no longer external. We might not have these windows in here anymore, or they might be looking down onto the kitchen dining room, but if they were internal windows, we may not want to model them. But we have these two walls here that now are modelling to the outside because Heatpunk can't see a room here, but actually that's not really what's happening. So instead what we want to do is just change these rooms to be the other side of these walls, to be a heated space. So we can see there I've changed that bathroom to be a heated space. And on the other side of this bedroom, I've also changed this wall to be a heated space. So now this kitchen dining room that has a double height kind of roof, but really it's a single story room, we are modelling our bedroom and our bathroom with the correct temperatures on the other side of those walls. The other thing to think about for something like a hallway is we could just come in here and adjust the height to 5 meters and press enter. And we now can see that that's been modelled at 5 meters, and we essentially have a double height space in here, and that might be fine. However, again, we've not factored in the upper floors. This bedroom is modelling to the outside when we know there is a hall or similar space on the left-hand side. And again, we could change these walls to a heated space. There is another way that we can do this though. So for example, if I was to just drop back down and I was to edit this hallway back to standard height, we have to remember that if we model two spaces on top of each other that have the exact same internal temperature, they aren't going to lose heat between each other. So if I come into my first floor, I could add my hallway, for example, or in this case, add my landing. And even though we're technically modeling two spaces, so we have a ground floor room and a first floor room with the hallway and the landing, we are modelling these as internal walls, as we would want to be doing, and we're not having any temperature loss between the landing and the hallway because they are the same temperature. And just to showcase that, if we came to our overview, a more detailed view of where the heat is being lost, we can see that there is no transfer between the internal floors of the landing or a floor structure of any type to that hallway. So the heat loss will be correct. Then we can simply say something, in our next section, we could simply override the landing and make sure that our hallway radiators below are actually covering the heat loss of both spaces. So we can model it as two separate rooms as well, if it's easier that way on your plans, or it's easier to get that across to the customer and you make sure that you're confident with your heat loss.